All right, welcome back, class. We are going to continue on our three rigid transformations where congruency is maintained through a single transformation. Previously, we did translation, as you can see here. That was a slide. We used the Geogebra software or the Geogebra application, which can be found in Clever, and we'll go there shortly. Under the translation that you did previously, you had plotted a polygon, a triangle, A, B, C. A was at negative 3, 5, negative 3, 5. B was at negative 6, 5, and C was at negative 6, 1. And then what we did was we clicked on translate by vector. So we clicked on the triangle and point A, and we dragged that point over here, which was a move of 8 to the right and 4 down. And we created the image, and we had the pre-image here. So we also wrote a rule, and the rule was that the coordinate x's and y's from the pre-image were moved plus 8 and minus 4. So we did that, and now we are going to work on reflections, which are a flip. So open up that previous document that you had. You can open a Google document by going to your apps, and you should see a word that says Docs there, and you just click on that and find the document that you previously had. Or you might, if you lost it, you might have to start a new one, but just you want it to be titled Three Rigid Transformations, Translation, Reflection, and Rotation. So at this time, please have that document open. You're going to be turning it in, all three of these transformations at the same time. So go back to Clever, and you're going to find the GeoGebra under, hopefully you put it in your favorites. If not, it'll be in a different section, and click on that. And your GeoGebra should launch without much of a problem. And here we have our GeoGebra screen. And there's a lot of things to push, but we don't want to push Start Calculator or Classroom Resources. We want to go down to this powerful math apps. And we're working in geometry, so we're going to click on geometry. Another way to get there is just to go geogebra.org/geometry. It might have remembered your previous work, so we're going to start from scratch. So we're going to click delete. And now we have our powerful geometry tool opened up. Let's take a look at our lesson. Again, your lesson can be found if you go all the way down to your Unit 1 lesson notes under rigid transformations and open that. You can always download it, and here it is. So these are the same notes. Unit 1, Lesson 1, the rigid transformations. We're writing the rules for translations, reflections, and rotations, and then we're applying those rules. So this was the triangle that we did previously. And we wrote the rule, and we looked at your book was page 454, has the rule or the key concept for translating in the coordinate plane. We discussed congruent figures having the same shape and size. So this blue figure, the pre-image, is the same shape and size as the image, the green triangle. And so the line segments are all the same. AB and A prime, B prime are the same length. And also all the angles are the same. So this angle here, ABC, is congruent to A prime, B prime, C prime. So they maintain congruency through the translation. Equally true is congruency being maintained through reflections. So if you look at this reflection in the x in the coordinate plane, when you reflect over the x-axis, everything's going to be equal distant. So we have, this is the x-axis, and so the point in the blue triangle here is 1 above, so its image is 1 below, because A reflection is a mirror image of the original figure. It is the result of a transformation of a figure over a line called a line of reflection. In a reflection, each point of the pre-image and its image are the same distance from the line of reflection. So this point up here at negative 4, 4, it's 4 units from the line of reflection. So the image point is 4 units below the line of reflection. And so you can reflect over this x-axis, and you can see what happens is the x's don't change. The distance left and right doesn't change, but they're swapping over the line of reflection. So your positive 4 for your y in this image becomes negative 4. So the rule is that for every x and y over the x-axis, all you have to do is switch the y coordinate, the sign of the y coordinate. So similarly, let's say we were reflecting over the y-axis, you're going to have the same thing, but the y's are going to stay the same. Like let's take this point, for example, in the pre-image. The y-coordinate is 1, and its image point is 1. But look at the x-coordinate. It's 2 units to get to the line of reflection. So its x-coordinate switches signs. And so you have a simple rule for that also. So we're going to build this triangle indicated here. Let me put the points in there for you. I'm going to add some text. Where is this point A located? It's located at negative 3. Oop, we got a little mistake here. Try editing that again. Well, negative 3 comma negative 2. And this point is at negative 6. Negative 4. And we have another point at 0, negative 5 for point C. The program messed up a little bit. I'm just going to write these points down. Negative 3, negative 2 for point A. And what we want to do is we're going to go ahead and reflect this over the x-axis and the y-axis using our Geogebra program. So go ahead and go back to the Geogebra program at this time. And we're going to click on the geometry tool, which we did. So now we're ready to go. So make sure that you're at geogebra.org/geometry. And we're going to start with a polygon. So we want to build a triangle. You don't have to put the points in the exact spot right away. You can put it in those 3 spots here. I can look at a better copy of the notes now. I can scroll down and say, okay, well, I want point A at negative 3, negative 2. So I'm going to go back to the move button and move A to negative 3, negative 2. I'm going to click on A and put show value. So I've got my A in the right position. Next, I'm going to go back to these notes. I'm going to move these over. And I need to put point B at negative 6, negative 4. Negative 6, negative 4 is point B. Show value. And my last point is at 0, negative 5 for point C. You need to make sure that you get the make sure that you get them in the right order also. So A has to be in this location, negative 3, negative 2. That letter A must be there. Letter B at negative 6, negative 4. And C is at 0, negative 5. Remember, being on move is really good because if you click on your triangle, you can move it around and it keeps its shape. So I'm at, again, negative 3, -2, and everything goes back to the right spot. If you want to move a vertex of a triangle, you just click on a point on the triangle. You can move it around. And if you click anywhere when you're on move, nothing happens. You can change your scale over here if you need to zoom in a little bit. We'll hit, this is really nice, to -8 and -5. Again, you could go in and out. Or if you want to go back to original scale, you could hit the home button. Okay, so we have our triangle. Now, in order to reflect over a line, we need to put a line in here. So we're going to put a line. Just click on line and click twice. 1, 2, and I have a line. And go back to move. It's important to go back to move. If you make a mistake, use the undo button. We're going to place this line on the x-axis. It doesn't matter where your point D and E, as long as it's on the line. To check if it's exactly on the line, you can zoom in a little bit. It's a little bit off. There it is. You'll know when you do the reflection if you're off a little bit. Okay, so we have our line, we have our triangle, we're ready to roll. We're going to go down to transform. It's at the bottom of this screen. We did translate by vector last time now, and we'll do rotate next time, but this time we're doing reflect about a line. So it's going to be a couple of taps. First, we're going to tap reflect about line once, select object, and then the line. So then you move to the right, select the triangle, and select the line. And scroll out just a little bit, and now we have our reflection over the x-axis. Okay, so we have that. We've got to leave this line alone because we're not performing a series. If I move this line at all, let me go back up to move. Be careful. If you move the line, you're going to be reflecting over a different line. So this line right now is the x-axis. But if I was to move it down here, this line is actually the x equals -7 line. So I've reflected over a different line. I want to reflect over the x-axis because I'm going to take a picture of this soon. So leave line DE there, and you're good with the first reflection over the x-axis. So we're going to add another line. Click on line and click 1, 2 points and stop right there to go back to move. If you need to run back the video to see it, just go ahead and go back a little bit so you can see what I did. You're in control of this, but we do need to move this line FG to the y-axis. So we have line FG here, and we're going to reflect over the y-axis. Let's make sure it's on the y-axis. Looks pretty good there. As I drag it down, it looks really good. It looks like it is on the y-axis. I'm going to go ahead and go back out a little bit. And I'm going to reflect. So I'm going to go back down, transform. No, we don't want to translate or rotate. We want to reflect. Again, you click on reflect. You're going to click on the triangle and then the line of reflection. So here we go. 1 click, 2 clicks, 3 clicks. The lines are really good. They look really nice. You can move the points around just a little bit so you can see that C is over here and C prime is over here so that we have it all set up real nice. This ends the first transformation. You want to screen capture this, so go ahead and screen capture it as a reflection. Take your picture, and then you need to go ahead and go to your document here under reflections, and that's where you're gonna insert that image. So you just took a picture of it, a screen capture, upload. We'll simply write the rule afterwards, and we'll be done. And then we'll do the So we have a reflection over the x-axis. So we need to write two rules: reflecting over the x-axis, and then maybe tab over a little bit and reflect over the y-axis. Just type that in there. I'm going to copy this rule really quick and paste it right here, and then I'm just going to pop in my rule. You can also look back on your notes here, because the rules were indicated here. If you reflect over the x-axis, xy is x negative y. Okay, so that makes sense. The y switch. So over the x-axis, it's x negative y. And then this one is opposite, negative x, opposite x, y. And we can prove that by looking at point A. Clean this up just a little bit. And there we go. Prove it by writing real quick. Last thing. Point A is located at -3, -2. So its point of reflection is at -3, +2. And here we have the same A. We just copy this and paste it in there. We just need to switch this. This is going to be +3 and -2. And then go just look up there and make sure you verify that that's the right thing. We'll call this prime. And this one's a prime. Oh, I'm sorry. This is A. This is your A prime. We'll call this A prime. I know I'm using the same letter, and you should have a sub number here, X sub Y, but we don't have the technology for that. So that's it for the basics. I would like for my enhanced class to just throw in the line of reflection over the y equals x line, and you can do that simply by graphing another line here, and that's the y equals x line. Then perform your transformation, you reflect, click on your triangle and your line of reflection, and then do one more line for your y equals -x. And that will do it for the enhanced class. You'll just pop it right here. Y equals -x. And again, it's going to be a little hard to see there's the original, there's your line of reflection. That's over y equals -x. Okay, save that document. You're going to be turning in all three. You're going to do rotations next. So good luck getting that